Okay, this is lesson 9.6. We're going to talk about multiplying and dividing radicals. It is very simple. First, we're going to go over the warm-ups. We have the square root of 50, m to the 6th, n to the 17th. 50 is 2 and 25, 5 and 5. Okay, I do have a pair of 5s. What we're looking for inside square roots, we're looking for perfect squares. Inside cubed roots, we're looking for perfect cubes. 5 and 5, 5 times 5 is a perfect square. It does make 25. However, because it's inside the square root of 25 is 5. That's why the 2 become 1 and move out. Okay? Now, what has to stay inside? Well, the 2 has to stay inside. But first, we need to deal with the m to the 6th and the n to the 17th. M to the 6th. 6 divided by 2 is 3. So 3 m's move out. 1, 2, 3, 4, 5, 6. That's 1, 2, 3 pairs of 2's. So 3 m's move out. N to the 17 is a little tougher. 17 divided by 2 is 8. So 8 n's get to move out. Now, there is a leftover, isn't there? There's 1 n left over. So inside my square root, I have a 2 that has to stay, and I have an n that has to stay. Okay? And that be that. Number 2 is a fraction. 36 is a perfect square. So this equals the square root of 36 is 6. This is just 18. It's not inside the square root. So my answer is 6 over 18. However, that needs to be simplified. 6 goes into both 6 and 18 evenly. 6 goes into 6 once. 6 goes into 18 3 times. So your answer is 1/3. The cubed root of 96, we have 96. 2 and 96. What's 96 divided by 2, kids? 48. 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. So now I have 3 2's right here. Because we're dealing with the cubed roots, we're looking for perfect cubes. Now, 2 2's and a 3 don't get to move out, but these 3 2's do. They're a perfect cube, so the 3 2's become 1. I keep my cubed root, and inside is 2 times 2, 4 times 3 is 12. 2 cubed root 12 is your answer. Number 4, I would like you to rewrite it the square root of 7 over the square root of 49. Because that's what this really is. Now, 7 is prime. So the square root of 7 is going to stay the square root of 7. Because 7 is 1 times 7. There's no pairs there. 49 is a perfect square. 7 times 7 is 49. So I get the square root of 7 over 7. That's my answer. Put 1. You can put 1 here if you want, yeah. You can put a 1 here. You don't have to. You can put 1 times the square root of 7 over 7, or square root of 7 over 7. Either way is fine. Now, this is how difficult multiplying radicals is. You multiply what is out with what is out, and what is in with what is in. That's it. If you need to pause the video to write that down, feel free. Okay, so here's how it goes. Notice how we color-coded things for you. Out is blue, out is blue. In is red, in is red. So I'll keep that going. What's 2 times 5? 10. Then we have our square root. Then we have red. What's 3 times 6? Well, that's easy, isn't it? However, are you done? No, because 18 can be simplified. It's not a perfect square. However, 2 and 9, 3 and 3. So 3 has to move out with the 10. So now I have 3 times 10 square root. What got left inside? 2. So 3 times 10 is 30 square root 2. That is our answer. You want to see something fabulous? You can put this right here, right into my calculator. Go ahead. 2 square root 3. Now, you have to arrow over. If you see that square root getting longer, it's going to give you the wrong answer. Arrow over times 5 square root 6. Arrow over to get out of the square root. Hit your equal sign. What does it tell you? 30 square root of 2. Make sure everybody gets 30 square root of 2. So now you can check your answers. However, on the homework and on the test, you have to show the work that I just did. You can't just use a calculator.
I'll get the 10.
What number is in front of the square root of 15 that's understood?
1.
Yep, there's a 1 here. So this is going to be 5 times 1. What's 5 times 1? What is 10 times 15?
150.
150. Now, you have to simplify the square root of 150. Somebody last hour asked me, do you have to simplify the 5? There's nothing to do with the 5. It just stays 5. Okay? What's that? What's 2 times 75? Oh, 150, yes. So let's go ahead and factor this. 2 times 75. Now we're going to have 5 times what? Five times. Well, let's go 75 divided by 5 equals 15. See, because 5 times 15 is 75. And then we have 3 times 5, right? So now our 5s aren't next to each other nice and neat, but there's 1 and there's 1. So those two 5s are going to move out, right? So I already have a 5 out there, and then I'm going to bring out another 5, and then what's going to be left inside my radical? 2, 3. I multiply those. What's 2 times 3? 6. So 5 times 5 is 25. This is 25 square root 6. Okay? That's your answer. Now, I want to check that. I want to make sure I'm doing it right. Well, I'm going to go 5 square root 10. Make sure you arrow over times, I don't have to put 1 square root 15, but I'll do it. 1 square root 15, arrow over, equals, what did it tell me? 25 square root of 6. There is only one way to learn math. In my math meeting yesterday, all of us math teachers were talking about this. We've all taken a ton of math classes at a very high level. And the only way to learn math is for you to do the problem, check your answer. If you did it wrong, figure out what you did wrong. Now, how do you figure out what you did wrong? You come in and go, I don't get it. And then I try to get you to look at notes to figure it out. If a teacher just sits there and tells you the steps, you're not learning it. You have to figure it out on your own. You have to. It's the only way to learn math. What happens if I give you the answers, kids? You just write them down. Last hour, I said this last hour, and when they went to do their worksheets, all they did was they didn't show their work. They just simply did it in the calculator and wrote it down. That's not teaching you how to do it. You use this to check your answers. If you do that on the test, just write the answer down. I'm going to mark it wrong. I have to see your work. Okay, number 3. What's negative 3 times 2? Negative 6. What is 7 times 5? Now, 35. Let's break 35 down. 35. That's going to be 5 and 7, right? That's it. 5 and 7 are both prime. Is there any pairs? So the square root of 35 is the square root of 35. Now, I'll check that in my calculator, but it'll tell me this right here. I'm done. Okay. You're going to do 4 and 5 once we get done with the recording. Right now, we have to do... Now, please pay attention because division is so much harder. In division, you divide what is out with what is out, and you divide what is in with what is in. Oh, shoot, that's the same thing, isn't it? Yeah, it is. I'll pause the video, give you time to write that down. Okay, here we go. Let me grab my blue pen. Oops. We're going to divide what is out with what is out. We're going to divide what is in with what is in, okay? So, negative 2 divided by 64, please use your calculator. What does that equal? Negative 2 divided by 64. Negative 1 over what? 32. Very good. Now, here, I'm not going to put this in square roots. I'm just going to go 40 divided by 2. What's 40 divided by 2? 20. So where does my 20 go? Does my 20 go on top or on bottom? It goes on top, yes. Does it always go on top? No. What if I had this? What if I had the square root of 2 over the square root of 40? Well, put that in your calculator. What does it tell you? It tells you 1 over 20, right? So in this instance, I would put the square root of 1. This would simplify to the square root of 1 over the square root of 20. Okay? But that's not what we have. So now, the square root of 2 goes away. Because 40 divided by 2 is just 20. So now, all I need to do is, can negative 1 over 32 be simplified? Because negative 2 divided by 64 is negative 1 over 32, right? Do it in your calculator. Put in your calculator. What does it tell you? Put negative 2 divided by 64 in your calculator. What does it tell you? No. Get the fraction. Hit the SD button. Negative 1 over 32. That's why I put negative 1 over 32. If it had been 64 divided by negative 2, then it would be negative 32. Am I done here? Am I done? What's that? Don't put the 1 at the bottom. There's no need for the square root of 1 down here. It just goes away. Am I done? No, 20 can be simplified, can it? 2 and 10, 2 and 5. So now I have a pair of 2's that come out. So now I have, this equals negative 1 times 2 times the square root of 5. All over 32. Because these two 2's come out, and then you multiply it by negative 1. So now, this equals negative 2 times the square root of 5 over 32. Well, shucks, negative 2 over 32 can be simplified. Go ahead, put that in your calculator. Negative 2 divided by 32. What does that equal? Negative 1 over 16, and I have to keep my square root of 5. Well, shucks, can I check this on a calculator? I sure can. Watch this. Let's go back to our original problem. In my calculator, you hit your fraction bar. On the top of the fraction, you put negative 2, square root 40, arrow over and down, 64 square root of 2, it equals, what does it tell you? It tells you negative square root of 5 over 16. Negative square root of 5 over 16. This right here, negative square root of 5 over 16 is the same as negative 1 times the square root of 5 over 16. The calculator will give you the right answer. You just have to check it. Okay, let's do one more. Let's go ahead and do number... I want us to do number 7. Okay? So, negative 8 divided by 24. What's negative 8 divided by 24?
Negative 1 over 3.
Negative 1 over 3. Very good. What's 175 divided by 25? Yes, but it's square root of 7. So, it's 7. It's not 1 over 7, so 7 goes on top. Can I simplify the square root of 7? Nope. Can I simplify negative 1 over 3? That's my answer. Okay, if you're watching this online and you have any questions, please come in and ask. Go to the Pace Lab, do something.